Okay, so we're ready to finish up lesson 7.1. So we are looking at two functions, f and g, and we need to find f plus g of x. So if we break this down, this is the f function, that's our g function, and that part right there says we need to add f plus g. So we can just write these out, 3x squared plus 7x, and then 2x squared minus x minus 1. And make sure when you do this that you line up the like terms. And then I'm going to put a little plus out here to remind myself that we are adding these two equations together. So we get 5x squared plus 6x, and then this is just like plus 0 minus 1, so that is just minus 1. So that's our answer. So the idea is not a new idea, it's just new notation to tell us to add the two functions together. With that, we can also do subtraction. So we're going to look at the same two equations, or same two functions again. And now this time we have to take f minus g. So we go 3x squared plus 7x. And we're going to subtract off, so I'll put that minus out in front again. 2x squared minus x minus 1. The hardest part of this problem is to remembering to always subtract. So we have to take 3 minus 2. Well, 3 minus 2 is just 1x squared. Then 7 minus negative 1. Well, 7 minus negative 1 is 7 plus 1, or 8. So this is plus 8x. And then again, we need to think of this as a plus 0 right there. So 0 minus negative 1 is really 0 plus 1, or just 1. So that's our answer of f minus g of x. Okay, we could also do multiplication with these. Oops, I skipped down too far, just a second. Okay, here's our multiplication problem. Now, yesterday we had some notation that, actually I don't think we actually saw that yesterday. We wrote f of g of like negative 3. Another way to write that is to say f of g of negative 3. Now that is different than f a closed circle g of x, because an open circle means composition, a closed circle means multiplication. So because this problem has a closed circle, we need to multiply those two functions together. So you can do this by distributing, or we can do the box method that we've learned in 9th grade. I need some space to work here. So let's start by doing the distributing method. Okay, it's kind of like foiling, but now we've got 3 terms to work with. So I'll do those two first. 3x squared times x is 3x cubed. 3x squared times negative 4 is negative 12x squared. All right, second term times it through. So I get negative 2x squared, and then plus 8x. And now we take the 1 and go through. And so we get 1x minus 4. Okay, if we combine like terms then, we get 3x cubed. These two are alike, so they make negative 14x squared. Those two are alike, and they make plus 9x. And then we just write minus 4 at the end. So that's the distributing method. Some of you may prefer to do a box method. And that's where we write it out as 3x squared minus 2x plus 1. Kind of space those out, and then x minus 4. Put the minus down with the 4. And then we fill this in. You fill it in by multiplying. So 3x cubed minus 2x squared, and then positive 1x minus 12x squared plus 8x minus 4. Then we go and we combine the like terms. So this is, that first box is where we get the 3x cubed. Those two make minus 14x squared. Those two make plus 9. And then there's the minus 4. So you get the same answer either way. It's just a different way of organizing it. So we've did adding, subtracting, multiplying, and dividing. Now it is time, or adding, subtracting, multiplying. Now it's time to divide. So this way tells us to take the f function and write it on top, or the numerator, and then the g function goes in the denominator. So we'd write it as 3x squared minus 2x plus 1 over x minus 4. So at this point, this is going to be as simplified as we can get it. In the future, we're going to have to look to see if we can factor that top part out, and then we'll be looking for things to cancel. But right now, this is good enough. But we do have a technicality we have to say. Whenever you divide by a variable, we have to put a qualifier in there that says x cannot be a certain number because otherwise the denominator would be 0. So what would make the denominator 0? Well, x minus 4 would be equal to 0 if we add 4 to both sides, if x were 4. And this one you can think it through, but I wanted to show you the work because sometimes they're a little bit harder. So we have to say that x cannot be 4 because otherwise it would make our denominator 0 and it wouldn't work. So this entire piece of information right here is our answer. Okay, now it's time to go back to composing functions. Before we were just combining functions by adding, subtracting, multiplying, or dividing, but now we are going back to f of x and g of x. So again, we're going to do this open circle notation right there. And so f of g of x. I would suggest the first time that you just watch this all the way through and then go back and rewatch it again so that you can write it down. So we need to track this through. We start with our g function, and we're going to put it into the f function. So let's look at our first term for g. 7 goes to 0, but now we have to look at our f function, look through all of the x's until we find a 0. Here's a 0. 0 goes to negative 1. So we would write this point down as 7, comma, negative 1. All right, let's do our next point. Negative 1 goes to 7. So now we try to find a 7. There's a 7. 7 goes back to 7 again. So negative 1 goes to 7. Next one. 4 goes to 9. And we look for a 9 in our x's. 9 goes back to 4 again. Whoop, I wrote that wrong. I'm sorry. 4 goes to 9. 9 goes back to 4 again. Oop, now it changes that. And then the last point tells us that 8 goes to 2 and 2 goes to 6. So we write that down as 8 goes to 6. Okay, so you may want to rewind that and look at that again. Okay, now let's do it the other way around. G of f of x. When we do it this way, we start with f and we go to g. So this is going to look a little bit different. So we start with our f. 2 goes to 6. Well, then we try to look through our x's and our g's to find a 6, and there isn't one. So we do not include that point. We just move on to the next one. 9 goes to 4, so we look for a 4. 4 goes to 9. So that point started at 9 and ended at 9. Okay, next one. 7 goes to 7. And now we look for x to be 7 in our g's. So we look at that point right there. So 7 goes to 7, and then 7 goes to 0. So we started at 7 and ended at 0. And then 0 goes to negative 1, and negative 1 went to 7. 0 started it, and 7 ended it. So that's how you do a composition of functions when the function is just a list of points. Now let's try composition of functions when our function is actually functions. Okay, so let's start actually with the easier one. So we've got two functions here. We have to do f of g of x and g of f of x. So it's going to be easier for us if we take the big equation and put it into the little equation. So that's going to be g of f of x. So let's do that one first. So what that means is we have to take what f of x equals and put it into the g equation for every x. Well, there's only one x, that's why I said it's a little bit easier. So we have to go to fill in our x with 3x squared minus x plus 4, and then it's minus 1. So I just rewrote out the g equation by putting the f equation in there for x. Okay, so then we can simplify that. 6x squared minus 2x plus 8 minus 1. And then combine like terms. 6x squared minus 2x plus 7. So that's how we compose the functions when we do g of f of x. Now, f of g of x is going to be a little bit more complicated just because of the way the functions are arranged. Now, to do this one, I've got to put g into f for every x. Okay, so we start by saying 3, fill in 2x minus 1, and that is squared, minus 2x minus 1 plus 4. Okay, so let's rewrite this then. 3. Okay, when we do this, it's 2x minus 1, 2x minus 1, because squared means it's times itself. So at this point, you can FOIL this out, but it would be really good if we can start getting into the habit of remembering our formula, which is a squared plus 2ab plus b squared if it was a plus b squared. But we have a minus b squared, so then the only thing that difference, or the only difference is that that's a minus right there. So we should write this out as our a term squared, so 4x squared, 2 times a times b, so we're thinking in our head 2 times negative 1, so minus 4x, and then b squared, which would be plus 1. Okay, now we're on to this part where we need to distribute this negative through. So minus 2x plus 1, and we still have the plus 4 at the end. Okay, let's FOIL or distribute this 3 through. So we get 12x squared minus 12x plus 3 minus 2x, and let's combine those two together, plus 5. And then we've got to combine other like terms. 12x squared, these two can be combined together to make minus 14x, and those two together make plus 8. Okay, one last problem to go through. All right, hit pause to read through this problem. So the difference is that if you take out your retirement before taxes or after taxes, you're going to pay less. So we first need to do $1,500 minus $100. So $1,400 is how much you would have to pay taxes on, and then figure out the tax by doing that by 0.04 for the percent. So that would be $56. Now the other way would be to take 1,500 times 0.04, and then we'd take up that $100 later, and so this comes out to be $60. So if he takes his retirement out first, he saves $4 every paycheck.